Over 70 million engines have been produced at the GM Tonawanda Powertrain Engine Plant since 1938. This is the story of the L-850. Before any engine begins the assembly process, its four main components enter the plant as raw metal. Precise machining transforms each block, crank, rod, and head into the fundamental workings of an internal combustion engine. Simply put, the block houses the cylinders and the rods. The crank pushes the rods up through the cylinders and into the head, where air and fuel are compressed and ignited. The first step in an engine's assembly is to marry the block to a pallet. For quality control and tracking, the two are not separated as they progress through the plant. RF tags on each pallet record each event and catalog the engine's assembly history via computer. Each head is removed and sent down through a separate assembly process, but will meet back up with the same block it came from when the lines merge. Once the upper and lower case bearings are put in place, oil is applied to the cylinders. Then, a unique ID number is lasered onto the block. Here, a robot installs the crank. Next, silicone is applied between the bed plate and the engine block as a sealant. "30 bed plate bolts are installed and run down. At this stage, the crank is turned several revolutions to test for binding. Once cleared, the rear seal is installed. Guide pins are set in place. Later, these will direct the positioning of the oil pan, the transmission, and the front cover. Here we see what's called a rollover station. There are several of these along the line. They facilitate positioning of the engine, readying it for the next process. To limit accumulation of dust, oil is applied just prior to installation of the pistons. While the block is assembled on one part of the line, the piston rod assembly occurs on another. Pistons are installed, followed by rod caps. These are run down at a specific torque and angle. Liquid sealant is applied, preceding oil pan installation. Critical monitoring determines if the rods are too hard or too loose, and microphone analysis determines internal noise and vibration. Then the engine is tested for leaks. With the main components in place, assembly of the engine's various inner workings begins. Manual and automated processes coexist on the assembly line, each with layers of checks and tests for quality control. In this phase of manufacturing, UAW Local 774 workers manually install kits and the timing chain. Then, the head gasket and head are added by automation and robots. Computer checks verify accuracy. The internal combustion engine operates based on a series of perfectly engineered explosions that occur when just the right amount of air mixes with just the right amount of fuel and is ignited at just the right instant. That timing is regulated within the engine. Valves must open and close with such precision that exhaust is expelled and fuel and air are supplied seamlessly. Here, workers install the oil control valve, followed by the flywheel. Then comes the cam cover, the crank sensor, the cam sensor, coils, filters, the access plug, and the knock sensor. After a successful rundown test, the front cover is fixed into place. A balancer or dampener is attached to the crank, and a belt tensioner is secured to the engine. Here we see the intake manifold being mounted. This is where fuel and air are supplied to the engine. A leak test is performed at this juncture. Compliant engines move down the line for dipstick tube installation and an application of oil in preparation for cold start testing. Cold test, named for the absence of fuel, breathes life into the engine and puts each newly assembled machine through a series of tests with extremely tight parameters. Ignition, oil pressure, vibration, cam phasing or valve function, exhaust, and torque are examined. After clearing the cold start test, the throttle body is installed, followed by the oil pressure switch and water pipe. Next up is the exhaust manifold. Then the coolant temperature switch and yet another leak test. Finally, the completed engine enters the ECV, or the doghouse. It's a computerized camera station that records dozens of angles and instantly recognizes abnormalities. And finally, the care job, a final visual inspection, as we strive for 0 defects and no warranties. With that, the engines are loaded for shipment. With this level of attention to detail and teamwork, it's no wonder GM Powertrain Tonawanda Engine is among the top performing plants in the General Motors family.